Hello and welcome to another Thursday night Q&A. I'm very pleased to say tonight I've been joined by a couple of my colleagues from the assessment team. First up, George Newham. Evening, George. How's your day been so far?
Evening, Sam. Yeah, been good today. Yeah, I've been into London actually, central London, King's Cross area, which is the area I cover is sort of North Essex. I don't normally sort of go that way, but sometimes we do. Some contractors sort of pre-arrange. That's where all the work is. We jumped on the train and headed into town. So yeah, it's been good. Been a good day.
Brilliant. And also James, who's also from the assessment team. Good evening, James. What have you been up to today?
Hey Sam, I'm based in the southeast, so I've just seen some new builds today, largely some nice simple new builds with some EV chargers, which are always good to see. Sign of the future, isn't it, I guess?
Yeah.
But yeah, and just a standard day really.
And any other renewables in the new build, solar or battery, or is it just EV?
No, just EV chargers. Just EV chargers, no PV or battery storage on these ones today. Yeah, it'd be nice. It's nice to see it, but no, not today.
Okay, without any further ado, we'll kick off. So as with all our live Q&As, we'll just run through a few house rules. So the first thing is we have to say that our team will offer advice and guidance based on the questions asked, but our guidance can only be limited to the extent of information provided in the question. We can't and do not assume any liability for any loss or damage caused by an error or an omission in the advice and guidance given, whether such an error or omission is the result of negligence or any other cause. If we do make reference to legislation, it's not to be considered as legal advice, and most importantly, individuals must rely on their own skill and judgment when making use of any guidance offered. So we'll start off with the question of the week that we posted out on Monday. And while we're waiting for people to post their questions in the chat, we'll go through our answer on that question of the week, and we'll look at some of the previous questions that have been posted in past sessions that we've not got round to. So please do put your questions in the chat. Remembering, as always, there's no such thing as a stupid question, only stupid answers. And please do remember to be courteous and civil to each other in the chat, because the whole idea of this evening is to collectively help each other out with the aim of improving our collective knowledge and understanding of all things associated with BS 7671 and the world of electrical installation. So without any further ado, let's have a look at our question of the week that we posted out on Monday. So this was one of those typical regs type questions. An overcurrent occurring in a circuit which is electrically sound is the BS 7671 definition of what? And the four options we gave you were A, overcurrent, B, overload current, C, fault current, or D, open circuit current. And when I had a little look earlier today to see how people were getting on, as you can see from the screen, the popular vote earlier was overload current. 70% of the answers, and at that time we'd had 1,500 votes. So that seemed like the popular vote. So what do we think? I think George is going to pick this one up for us. What is the correct answer, George?
Yes, that's good to say. Well done to everyone that did put that. The correct answer is B, overload current. So to get that answer, you'd have to go to the definition section, part 2 in BS 7671, and then obviously the answer is kind of in the question, actually, definitely with the definition mentioned, but it does say overload current. Read the definition: overload current and overcurrent occurring in the circuit which is electrically sound. So that would be the correct answer. There was some definitions of some of the other answers as well. We had overcurrent is actually a current exceeding the rated value for conductors. Rated value is the current carrying capacity. Obviously, fault current is a current resulting from a fault. And answer D is kind of a bit of an anomaly, because you wouldn't really get, with an open circuit, there'd be no current that would flow. So that kind of rules that one out. So yeah, so well done. For the majority then, I think you said, Sam, is that right? The majority put B?
Yeah, we had 70% had the right answer.
Yeah.
Which is good.
So whether that looked up or just sort of off the top. But yeah.
Yeah, essentially it's a fundamentally sound circuit, isn't it, from a design point of view? I mean, you could have a loading it's been poorly designed from an overload point of view, depending on what its use is, but generally it's a sound circuit it's being overloaded.
Yeah.
Yeah. Yeah.
Okay, so as I say, we'll pick up some questions that we didn't get round to answering last time round. While we're doing that, please do post your questions in the chat, and we'll pick those up. So the first question is one that we do get asked from time to time with all the building work going on. So on a construction site, do the site offices have to comply with the requirements of Special Location 704 for construction and demolition sites? So what's our thoughts there, James?
So generally it's a no. Well, most of the time it's a no, because the requirements of 704 specifically state the section does not apply to installations in administrative locations or construction sites, e.g. offices, cloakrooms, meeting rooms, canteens, restaurants, dormitories and toilets. The rest of the general requirements of Part 1 to 6 apply. And the main reason for it is just primarily because they're permanent structures, a lot of them, or they're semi-permanent at least, and they're normally located quite far away from the construction site itself. So you're just not introducing as many hazards that, like erection of steel work and that sort of stuff coming from the ground, because one of the primary concerns in that section is the open pen conductor and not using PME, and because of all the dangerous potential differences that can occur. And then buildings are set away, so they're away from all the erection of the steelwork, so they're just not as seen as much a risk. And you get a strain into other sections of the regs as well. And marinas, the permanent buildings have a set that aren't included just because there's no risk, or much less risk, should I say. Yeah,
I think the perceived risks is associated with the environment, which on a construction site is external. And as you say, overnight, lots of structural steel can be installed, and so now we've got more things to consider. Whereas, like you say, in the offices and the canteen, they're more permanent structures, and the perceived risk isn't the same because it's not the same environment at all.
Yeah.
Okay.
Yeah.
Another one. Again, this is quite a common question. What classification code should be given to cables buried in a wall at a depth of less than 50 mil without the additional protection of an RCD? George, I think you're going to pick this one up.
Yeah, this comes up a lot, actually, quite a lot on assessment. I think the information's out there. We always refer to any coding. First thing that always comes to mind is the electrical safety first, best practice guide 4, domestic and similar, and it's got his guidance, domestic and similar, but industry agreed. Doesn't cover obviously every code for every possible thing. There's always some sort of engineering judgment, but for some of the key ones like this one, you can see it in there, clear code 3, improvement recommended, absence of additional protection by RCD for cables installed at a depth of less than 50 mil from the surface of a wall or partition. Obviously, we're talking about PVC cables. They do not incorporate, obviously, earthed metallic covering, armoured, etc. But just standard PVC, code 3. Yeah. And I think, I think that's also on the RAG as well. To be honest. I think that's on there. A lot of people. There's also a question and answer section on the actual Electrical Safety First website. I think that appears again there as well. So that's obviously a common one.
Yeah.
But I think that makes sense. It may not comply to the current regs as they stand now. Things have changed over the years, but what is it potentially dangerous? If a cable did get drilled into or nailed into, you should still have bolt protection. If it hits the line of earth or the line of neutral, talking about additional protection here for the 30 milliamp RCD. So, yeah,
in general, the keyword's additional, isn't it? It's an added protection method, isn't it? I think, and because it's an added protection method, you've still got your basic and full protection. The risk is a hell of a lot lower, isn't it?
Yeah. Being the zones as well. Obviously, for new install, obviously it's required. We have to, if we're putting a new circuit in, we have to provide that. But from an EICR, obviously we are looking, still highlighting it to the client, still telling them that it doesn't comply to the current standard. But it could still have a satisfactory outcome, depending on what else is found. So but it does come up a lot. But it's a good thing when it does come up, because then you can always mention that best practice guide 4, which then that also, if anyone's not aware of that then sort of highlights other things, other RCD questions and coding. So it's always a good topic. And
as you both said, it's the additional protections. As long as we've got fault and basic protection, we're happy that the installation's safe for continued use. And the other thing that you mentioned, in reality, it's not that long ago that RCD protection for cables in walls were introduced. So it may be that the installation of those cables had already taken place, and as 7671 tells us at the front of the book, just because an installation was designed and installed to a previous version doesn't automatically make it unsafe. So, okay, good stuff. We'll move along. Another one that we get an awful lot to the technical helpline still is, can a new circuit be added to an existing plastic or all insulated consumer unit? James, what's our thoughts there?
And again, generally the answer is yes, assuming the sort of basics, the adequacy of the enclosure is sound, so no signs of overheating. It's fit for purpose. The barriers and enclosures is maintaining its IP ratings. Your 4x XXD on top, 2x XXB bottom and sides. It's also been answered on the RAG. The Wiring Regulations Advisory Group, where it's got the question and answer section. Question 100 says generally it's okay, assuming that there's no obvious signs of degradation. And we also did an article on it. Would have been sent to the contractors via email on the 15th of August 24, and it talks about a periodic verification, having a look at the installation, reviewing essentially. On any installation, when you're doing addition, if there's any code 1 or code 2, there's generally you should be putting them right before you complete the works. Any C3s, generally we can likely go ahead as long as they're not impacting the overall safety of the installation. Anything of note you can identify as a defect on the certificate and just make a note of it, really. Obviously, when it was installed, it would have complied at the time, and it ultimately would have complied with electricity at work regulations at the time. So we change and we improve, but that doesn't mean what we did was unsafe when we did it.
And I think people do sometimes confuse that fact that because current requirements now require it to be in a domestic situation non-combustible, they feel then that it has to be, and the advice, the industry advice, best practice guide 1 follows it as well, we follow it, is that if it's in one of those locations where you would give it a C3, then it would be a recommendation to consider change in that consumer unit, but only a recommendation, not a requirement. Good Good stuff. A great question that a lot of people get a little bit confused. George, what's the difference between U and UO when you're completing an electrical installation certificate?
Yeah, so again, this another one comes up quite a lot actually, is a sort of clerical thing really. Talking about the voltage, so nominal voltage on a certificate or a report. You've got the U value and the UO value. So U is actually voltage between line and line. So this is only going to be 400 volts for a standard three-phase arrangement. That would be 400 volts between line conductors. And if you've got a single-phase installation, then that's going to be not applicable. Whereas UO, that is your voltage from line to earth. So in a single-phase situation, nominal is obviously 230 volts. But also in a three-phase situation, it's still line to earth. It's still 230 volts. So that's just the ways of things to remember. U generally 400 NA, UO 230. Yeah, that does get mixed up quite a lot. But yeah, it's really simple when you remember the key, basically what they are. It's a pretty simple one. Yeah, again, definitions, I think. Yeah, symbols. So if you look at the list of symbols, part 2, again, definitions, it will actually tell you that as well. So I think people maybe, sometimes with the line and live, people maybe get confused because neutral is obviously a live conductor, as is line, but the phases are line to line. So that would be the 400 for a three-phase. Yeah, that might be where it comes from.
I don't know about you, George. A lot of the time, I think it's just an error on the software, because on assessment, if I point it out, a lot of them just say, "Oh yeah, it's a lot of it's just a copy and paste, isn't it, on various softwares that drag it in." I find so it's just looking out for that when you're doing the certificate, really.
Yeah, it can be a little O or something. Maybe they see the U, but there's a little O next to it. So yeah, maybe.
Yeah.
But no.
And I also think sometimes people are nervous about putting not applicable on a certificate, especially when it comes, right towards the front. So they feel it has to be a value. But yeah, and quite, I've seen an awful lot of certificates where it just says on a single phase installation 230 in both. And then when you question why, and they say, well, I wasn't sure which, so I went for both. And it then kind of dilutes a little bit of understanding and makes you scratch a little bit further. But
yeah,
there's autopilot as well. If you did a lot of single phase installations, then you do a three-phase one after a month or two, and just autopilot. But yeah, it just goes into show, checking what we're looking at, the different characteristics, and get a little prompt on there.
Good stuff. We'll take a few more, please do. We've got some questions in the chat now that we'll transfer to in a minute. That's really good, but we'll look for more. So we'll just finish another couple, and then we'll dive into the chat. So James, what's our advice to contractors when they go to a PME, a TNCS system, and they measure a ZE that's greater than the quoted value of 0.35 ohms? What's our guidance there?
Well, first of all, the 0.35, I think it's found on the earlier pages of the on-site guide, is generally guidance on ENA guidance over the years, and it has changed. Fundamentally, obviously, when you're on site, if you want to be achieving ADS, as long as you're achieving automatic disconnection of supply, then the installation's safe. You're meeting your disconnection times, your maximum ZSs. So as long as you're reaching them, then fundamentally it's safe. So then really it's sort of weighing up, is there signs of degradation from it? On the NICEIC Pocket Guide, at Pocket Guide 30, it gives the latest ENA guidance on what's expected in a domestic property. On a 100 amp 230 volt supply, it says that 90% of properties you should have less than 0.34 ohms. 98% of properties less than 0.64 ohms, and 2% of properties should have greater than 0.64. So that gives you an idea of how they're looking at it and sort of what you would consider acceptable, and that's for TNCS and TNS, I believe, from memory. And so generally, yeah, as long as you're achieving your ADS, and if it's obviously starting to climb high, then there's clearly a sign of problem, because PME generally is going to be pretty damn low, isn't it? It's using a neutral conductor.
Yeah.
Just pay attention to it, and if you think there is a sign of a problem, then get the customer to contact the DNO.
Yeah, I think there's sometimes people remember the value, but it's a typical value, and it's really there for us when we're designing. So when we're designing and there isn't a supply that we can measure, we can use that value of 0.35 as our design. But it's not. Some people are under the misconception that that's the maximum and the DNO have to achieve that, and that's just not true. So it's a typical value that's really used for design. And if we are exceeding it, then as James said, if you've got evidence that that's getting worse, so from the original install to the first periodic to the next periodic, it's increasing, then that information tells the DNO that something's going wrong. So it's always good if you've got that to let them know not just the final value, but the initial values and when those times were. But ultimately, as James said, if you're achieving your ZS, maybe perhaps because you've got RCD protection or RCBOs on all the circuits, then you're safe to carry on the install. But what you might do is you might factor it in when you come to recommend the date for the next inspection. Certainly, especially if you see it deteriorating. But okay, we'll take one more and then we'll dive into the chat. So again, another common one. Does a circuit supplying electric vehicle charging equipment require RCD protection? I think George is going to pick this one up for us.
Okay, yeah. So the circuit supplying it, not necessarily. So yeah, obviously EV charge point itself would require an RCD 30 milliamp, but the circuit supplying it, not necessarily. No, obviously we'd have to be mindful the general requirements of BS 7671, but it is a distribution circuit generally. So if that was wide surface, if that had if an armoured was used to overcome the other requirements, if as long as it's not a TT, obviously if it's a TT, then it generally have an RCD for fault protection for that. Might not be 30 milliamps, but RCD for that. But no, you could design that out, but it would be the actual charge point that would need one. So that could be downstream or at the actual charge point itself. But as long as that's covered, yeah, then just general requirements would apply. I would say whichever one is in place for the charge point, it just have to be obviously to the appropriate BS listed in section 722, as you'd expect. But no, you can design that out for the circuit, which could be necessary sometimes for various reasons.
Yeah.
There's two separate things going on there, isn't there? There's the circuit and then there's the socket outlet of the EV charger, and you're considering them both separately, really, aren't you? And a lot of the time it's accomplished by on the front ends doing both because it may need it, but yeah, it's two separate things.
Yeah, there will be times where that's the most, as per the designer's choice, that might be what they choose to do. That may be the easiest option, and that's fine. Same as socket circuits, it's the sockets that require, you can design that out, but a lot of the time you do just put it at the circuit. But no, it just depends. Every scenario is different, especially in a commercial factory. You might have a distribution circuit that's doing different things, and you may want to avoid it. So I know, yeah, that does come up because you think 722 car chargers must have RCD. But yeah, the point itself.
Yeah.
And if the RCD is upstream, it needs to switch both line conductors, doesn't it? So live conductors, shall I say? So.
Yeah, it'd have to disconnect both. Yeah, whichever RCD, is there. Yeah, that's a good point, isn't it, James, to add that? Yeah, both live conductors.
Okay, that's great. We'll dive into the chat and see how many of those questions we can get through. There's some good questions, and the first one may be a little bit controversial, so I'll take my hat off and try and give an answer to that. So, first question that came in tonight says, given the IET and BEMA's joint statement, although it's not an IET and BEMA, it's an ENA and BEMA, given the ENA and BEMA joint statement this week on SPDs, what's the NICEIC's take on the provision of an overcurrent protective device for SPDs, required or not? And yeah, so as the engineer that's posted the chat recently, I think it was actually last week, there was a joint guidance note published by the ENA and BEMA, ENA being the overarching organisation that sit above all the DNOs. So they're there to represent all of the DNOs around the country. And the statement was about whether you could use the service fuse or cutout fuse for overcurrent protection of an SPD. Now, we are actually putting together something on this, because one of the things that we've always picked up in, although BS 7671 allows you to use SPDs with either integral overcurrent protective devices or an SPD and then supply it with a separate overcurrent protective device, there's also a requirement in 7671 that the overcurrent protective device that you use to protect the SPD cannot result in the failure of that device mustn't affect the continuity of the supply to the equipment. It has to be unaffected. So if you have a look, I know we shouldn't quote reg numbers off the top of our head and give you page numbers, but I had a sneaky look at it earlier. It's right at the bottom of page 169 of the current Brown book, 534.4.5.2, and it says, in case of overcurrent protective device operation arising from SPD failure, the continuity of the supply to the equipment is unaffected. However, neither the installation nor the equipment is protected against possible further overvoltage. In such arrangement, the effective voltage protection level within the installation is increased due to the additional volt drop at the external overcurrent protective device connected in series with the SPD. So that's our thoughts. If you were to use the service fuse, then obviously if that operates, the supply to your installation is affected, and so you would directly affect the continuity of supply. But as I say, we're actually looking at this week or next putting something together on guidance on that, because that's our thoughts at the moment, although it is currently being reviewed. James and George, have you had any conversations about that guidance that was pushed out last week?
You go first, George. You gone?
Yeah, and before that guidance, well, I had a few people asking about it. I don't know if there's been things on sort of other sources as well. Maybe had a few people asking about if this actual surge protective device had a inbuilt fuse of some sort itself was coming up as well, and we were sort of, if the manufacturers could sort of confirm that, then that might have been another thing. But yeah, mainly probably before that document actually. Obviously that document's now come out, and then so it's good that we're doing something, because I do feel for in some of the contractors they just go there and get a fuse board sometimes and fit it, and it's good that people are asking about it and reading them documents and wanting to do the right thing, and but yeah, what's your thoughts on that? If the actual SPD had a fuse of some sort in it itself, but obviously for the intricate side of it, that's getting into sort of the actual product. I was
just going to say, now, I mean, in how I see it, I mean, it's only my opinion. I mean, it is a type tested piece of equipment, that whole consumer arrangement, isn't it? So they're all manufactured equipment, and it's normally it's built into even the DIN rail, isn't it, and the buzz bar. So I mean, if it's a type tested piece of equipment to 614393 series, I mean, Sam, what do you think? How do we view that?
Yeah, it's just the fact that 7671 requires the SPD to have overcurrent protection, but it doesn't specify that it has to be integral, and it doesn't specify it has to be external to the SPD. So it can be either, because at first we saw SPDs that didn't have it, and then we started to see SPDs that did have it, and now we're starting to see combined main switch with an SPD with an overcurrent protective device, because for manufacturers there's obviously an advantage to modularize all those things together. But so we recognise that the SPD has to have a form of overcurrent protection. There's both forms are accepted, either integral to the same device or external. We sort of are happy with that, and it's just that other regulation then that talks about continuity of supply. That's where we've got the concern. Well, does that preclude the use of the DNO fuse?
And I suppose how we guarantee that integral fuse, should we say, that if it did have an integral one, I guess that'd have to be the manufacturers to confirm that it's got that fuse, perhaps. Maybe.
So great question, and as I say, we are working on, so in the next few weeks hopefully we'll have some documented guidance ourselves out there. So another question, again a great question. If I'm replacing a consumer unit which also has distribution circuits connected that then supply additional consumer units, do the final circuits need testing when I replace that consumer unit? So we've got a distributed architecture. We've got a consumer unit that's, if you like, the main consumer unit that has some final circuits, but also distribution circuits coming off it. When we replace that consumer unit, what's 7671's requirements with regard testing? I think this is one of those cases where that's the extent of work covered by this circuit is extremely important, because you can put that you've only replaced that consumer unit and that you haven't installed those distribution circuits leading it, and therefore you've not done a full and complete test of those. There's no requirement in 7671 for you to do that, but we would strongly advise that you make that very clear in that box which says extent of work covered by the certificate. Would you add anything more to that?
Well, Best Practice Guide 1 gives guidance on replacing a consumer unit. So it is guidance. I think, like Sam says, it's the extent of how you describe the extent of your works, really. I mean, I think generally it's good practice, best practice to at least check ADS is achieved on the protector devices you've put in. Just check sort of the end of lines, the general basics, really. Check, going back to what we said earlier about there being no dangers present. It's sort of within your duty of care to be open-minded. But yeah, the description of works really defines what's within the scope of your works, really. So yeah, if you're quite specific, I'm replacing consumer unit only, testing what's been changed, then that's the scope of works.
Yeah, I think definitely best practice, isn't it? And generally, I find people do that. I think obviously you wouldn't then have, if you're in a building, you don't need best practice to test them. So if you then got subboards and stuff, then you wouldn't necessarily have
where
just a full installation. Where would you stop? But just them first ones, Best Practice Guide 1.
Yeah.
I mean, particularly if you change any characteristics, if you put sort of different devices in, they may have different max permitted ZS values, and then just to confirm that obviously what you've done hasn't detrimentally affected anything as well.
No,
it could be like obviously, yeah.
That's a really good point, George. Actually, if those existing circuits, if they're remaining, but you're changing the protective device, so it's got different characteristics, then yeah, you need at least to have a look at the things like ZS from perhaps from a previous installation certificate or a previous condition report, to confirm that your new protective devices will still be adequate. That's a really good point. But yeah, the key is that box on the certificate which says extent of work covered by the certificate, because otherwise, if you think of a large installation, if you had to check every circuit that led from that board and then every circuit that led from the sub board and so on, yeah, you would never change a board on a large installation, basically, because you'd have too much work to do.
And it would end up preventing, like, good work going. Like, there might be a need for that change, and it would end up, the customer would end up maybe not doing it if you said I was going everywhere and costing a lot more time to test. They just need that bit of work done, and we don't want to prevent upgrades being done.
Yeah, spot on again. I come from an industrial environment, and I've seen a distribution board taken off the wall by a forklift truck that was full. So yeah, a distress change, you need to be able to do that to maintain the safety of the installation. One area that we perhaps might need a bit more information. So one of the engineers tonight has said, recently saw a debate on coding for RCD main switches covering all circuits. And the debate he saw wailed on about whether it was a C2 or a C3. First thoughts are there's nothing to say that just because it's that, you can't have an RCD looking after multiple circuits. Back in the old days, as you said, we had one, then we went to dual boards. There's a requirement now in 7671 about nuisance tripping to not achieve that 30% value, I think it is. But you would need to have some evidence that was an issue before you started thinking about coding. But just because an RCD is looking after multiple circuits, our advice would be there's no code involved in that directly, unless you've got evidence that the accumulative leakage from all of the circuits it was protecting was resulting in nuisance tripping. But as I say, you would have to have evidence of that. James, George, any thoughts on that one?
Yeah, I mean, there's two things. There's unwanted tripping 531.3.2, where it talked about, as you said, Sam, limiting sort of the amount of risk of unwanted trimming by subdividing circuits. But ultimately, if you're doing an EICR, you're checking the safety. I mean, what's the worst that can happen there? The RCD is going to go off, but the electrical installation is still safe, isn't it? So unless you've got a cumulative sort of protective conductor currents, earth leakage, that sort of stuff, then and you're going to get unwanted tripping. But again, it's a C3 is something that's going to whilst it's not potentially dangerous, it will enhance the safety of the installation, and generally that's not going to. It's just going to make it a bit nicer to use, shall we say, or nice to be monitoring, working with, I guess.
Yeah.
Yeah, and you could look at the service, if from an ERCR, that installation's in service. Has that ever happened? In how long it's been there for, and could come into play, as well.
Yeah. Another one that's come through. I need to replace the consumer unit. However, the tails supplying the consumer unit are about 4 meters in length and potentially buried in a wall at less than 50 mil from the surface. It's not possible to replace the tails due to damage to decorations. Is it okay to omit RCD protection to the existing tails and comment on the existing installation via the certificate that RCD protection is not provided to cables within a wall? Do I need to install a switch fuse isolator to protect the existing tails? A little bit similar to what we've said before in terms of if those tails already exist, then the extent of your work is the replacement of the consumer unit. and not directly the tails. You make it clear you've got the extent of work covered by the certificate. You've also got the box which says comments on the existing installation, where you can make any concerns aware. But yeah, there's nothing that says you need to replace those tails, or you need to provide the protection that it's want. But use those two boxes correctly. Provide all the information, make it clear what you've done and what was there already. The other thing I also pick up on that is 4 meters away. Generally, the DNO will only allow their fuse to be used for protection of those tails up to 3 meters in length. So again, it's worth recording that fact that was there already. Yeah, in terms of it wouldn't preclude you from doing that board change.
I think that was a good analogy James said earlier as well, about looking at things, if there's, when you're doing alterations and additions, looking at when you're judging, is the existing installation adequate, the key word being adequate, and looking at things, are they code 3, code 2 items, whereas a code 3 item may be adequate, maybe for what you're doing. Yeah, whereas a code 2 might not, if it directly affected, obviously, the safety of what you're doing.
Yeah.
Yeah, it's a defect, sure, but you can still go ahead with just make sure you can record the defect, but still go ahead.
Yeah, that's really good what they said as well. Comments on existing. That's obviously the exact place. That's where to put it. Yeah.
Yeah. An argument, this is me reading, it's not me, I didn't witness anything. So an argument has erupted on site. People believe with prefab wiring that you only test to the area distribution box and not the plug branch circuits that come away. I find this to be idiotic, and that the prefab wiring should be tested to the very last point to prove the earth fault loop impedance is adequate for ADS. Any comments on this? What do we think on that?
You go first, George, if you want.
Yeah, I think again, it's that extent is clear. Who's responsible for that? We've got to look at who's responsible for that section. Who's going to energise that? Because obviously, if that's someone may have, don't know if anyone has carried out initial verification on it on construction, but then obviously that's been relocated. So sometimes they might do some initial verification on construction. But obviously someone's installed them cables, and so sometimes they'll say next inspection when installed. So then someone has got to go, what's your extent? Are you doing all the suppliers? If you're then going to connect that and energise that, then obviously I'd say you've got to make sure that's adequate. Speak to the client, say, look, do we do any ICR on this pre-installed because we haven't installed it? Do we do any ICR on it, or do we just include our extent is what we've done, and we're going to connect this and confirm it's adequate? Yeah, what do you think, James?
Quite a difficult one, isn't it? I think it's like I say, it all depends who's responsible for what, doesn't it? Them circuits do need commissioning as such, don't they, and verifying that ADS is met by someone once the earthing conductor is connected to them through various means. It's the functionality of the RCDs and that sort of stuff. It does need proving, doesn't it? So at some point that's going to have to be done, but I suppose it depends who's responsible for what in that installation, isn't it? If you're stopping at the supply to that, then, and that's your contractor works and your description, then then what gets done after that's someone else, isn't it? I think.
Yeah, and
different scenarios, couldn't there, on different projects, different things going on there. Yeah,
but it is becoming more and more practice in construction that we're getting modular. We're getting modular units. I saw recently where it was a block which was going to eventually be student accommodation, and the toilet, bath, shower was a pre-built module off-site, which then was come in and assembled. So, like you say, if hopefully that will have been tested while it's under construction off-site, but then there would still be some tests required when it's on-site, because now the supply will be different to it. You would also want to do some checks in terms of making sure it hasn't been damaged during its transportation and its installation, but again, that needs to be resolved as to who's doing what. If I'm installing a supply cable to a bit of equipment that may or may not have its own product standard, then does my responsibility, it's up to you and the end user, your customer, to determine where because your responsibility could end at the end of your supply cable, and then it's down to somebody else to do the overall integrated commissioning and tests. But ultimately it would need to be done, because as James and George have said, you want to do that, and you want to also ensure that it would be good practice, I think, to at least sample some of those tests that were done wherever the units were manufactured, wherever the pre-made cables were manufactured, just to ensure that you're still getting the same results. So you can have confidence in the transportation and installation methods.
I think also, I mean, as a minute, I think what I would do if I was in that situation, I'd probably check the functionality of the RCDs. Prior to that, I'd do an R2 lead as a minimum to all the exposed conductive parts, because with that as ZE R2 and your RCDs, then you have proved ADS, haven't you? So I mean, as a minimum, I think that's what I would do, and that wouldn't take long, would it? I don't think checking the RCDs and some R2 lead.
Yeah, nice wander lead, and it wouldn't take long.
A bit like a portable building. When they're constructed, they'll sometimes obviously test them on construction, but then when they're then located, then obviously you've got to check before they're actually fully energized, what's the supply, is fault protection still in place from this supplier, energizing there, some responsibility there. And if it can move, certain cable types may be more and less suitable for moving a building around. If you started checking connections and you did identify a problem, then that's something obviously needs highlighting. The client's then got to look at that, and different scenarios may apply to different specific projects on who's doing what. I think on that
it's
one.
I think it's all in the contract, that one, isn't it?
Yeah. Yeah, because it ultimately has to be done, but not necessarily by the installer who's running the cables to those prefabricated units, prefabricated wiring systems, products even, maybe. We're running out. Let's one more question that we had in the bank was again a common question. Plastic water service entering a property, which is then converted to metal within the property, probably for looks, for aesthetic reasons. Does that require equipotential bonding to the metallic pipework? So plastic water surface service coming into the property, then converted to metal within the property. Does the metalwork require equipotential bonding? Who's on this one? I forget who's first.
Yeah, I think it was me on this one. I think.
Okay.
Yeah. So the answer in most cases will be no. It's if that metalwork then goes back into ground, then it's now introducing extraneous potential difference, or potentially has. Assuming it's plastic, comes in plastic, turns to conductive material, stays above ground. It almost certainly won't need bonding, but if in doubt, you've got Pocket Guide 35, which tells you how to test for extraneous conductive parts, and essentially that is a test of the system earth rising to up to 230 volts under a fault condition, and you'll measure between that reference point. You'll use the formula 230 divided by 30 milliamp, because that's the maximum value. Is a safe value for which a body can survive with, and among other things. But yeah, 230 divided by 30 milliamps. 7,670 ohms. So if it's below that value, the milliamps are going to climb. If it stays below that value, So the higher that resistance value between the two parts will tell you how much current will flow through your body with 230 volts on the system earth. So yeah, so it's not that's probably overcomplicated. As long as it comes in plastic and doesn't go back into ground in conducting material, then almost certainly it won't need bonding, because it's just an isolated piece of metalwork which you have all over your house. So we wouldn't bond all of them. So yeah.
There's a note that was added. Was that in Amendment 2 when they added that little note in there in the actual regulation? Yeah, saying that it wouldn't normally.
Yeah, it specifically says it, doesn't it?
Yeah. Okay. Well, just before we wrap up, just to give you some more guide. If you are in the audience tonight and not currently certified with ourselves, then please, but are looking to get certified, then please do go onto the NICEIC website, where we've got information about our electrical schemes, our renewable and MCS, hazardous area, fire alarm, for those outside of England, certified construction in Scotland and the Jersey scheme. So if you are looking for certification, please do go and look on the NICEIC website. Likewise, training, if you've got some training requirements, again, I was in our Dunstable training office earlier in the week, talking to some guys on a fire alarm course. So again, electrotechnology, electrical technical, MCS and renewables, emergency lighting, fire alarms, plumbing and heating also. So yeah, if you are looking for training, then please do go onto the NIC website. Event wise, what have we got coming up? So early part of the year, we've got 4 of the 6 ELEXs, so we are up and down the country literally. So the first one is at the beginning of March in Bolton, at the football stadium, the Bolton Arena, on the 5th and 6th of March. We're down in then Alexandra Palace on the 26th and 27th. In April we go to West Point in Exeter. And then in May we're at the Yorkshire Exhibition Centre in Harrogate. So if you are around there, please do consider come and see us, talk to us. We'd love to see you on the day. And any final thoughts, gents?
No, I've enjoyed tonight. Thank you for inviting me along, Sam, and George. It's good to spend the evening with you. What's left of it.
Likewise, yeah, it's always good to see colleagues. We're out in the field a lot. So, yeah, thanks everyone for their engagement. There's some good questions there, and that's what it's about at the end of the day, yeah. Cheers.
Yeah, very much so. And some really great questions in there. I do apologise. The earlier ones disappeared, and I can't seem to be able to scroll them back. That's my fault, not the unless I'm doing something wrong with the system. But we will try and get hold of some of the earlier ones, because they same old. They nothing happened at first, and then once one came in, they started in a flurry, and very quickly scrolled off the bottom of my screen. So I didn't get a chance to catch them all, but we got as many as we could, and those we didn't get, we'll recover and we'll use them to start next time. Talking of next time, next one will be in exactly 4 weeks' time. The magic of February is that it is an exact 4-week month. So next Q&A will be on the 5th of March. We've got some wire webinars coming up for our NICEIC certified contractors before them, but again, the open Q&A night will be open on Thursday the 5th of March. So please do come. Keep looking out for us across social media, across Facebook, Instagram, Twitter and LinkedIn. We always do post out our questions of the week, and if you've got some questions that you'd like us to include, then do put them in, and we'll try and get them included in one of the Monday night Q&As. But yeah, thank you everybody for taking part tonight. I did see some people helping each other out within the chat, which is great, because as we said at the start, whole idea of this evening is that we help each other out so that our joint learning of BS 7671 and everything electrical is improved. So thank you very much for taking part and contributing. I'm just going to leave you, the last slide we'll leave up for a few minutes is about the tools to talk. Towards the back end of last year, we did a piece with the Electrical Industries Charity about the importance of actually looking after each other and talking. And remember, the Electrical Industries Charity isn't just for those of us lucky enough to be working in the industry, it's also for their relatives as well. So please do, if you need to, get in touch. A great charity, and it does great things. So from us, and on behalf of George and James, thank you very much. Thanks very much for the great questions. Apologies if we didn't get round to answering yours tonight, but we will pick them up and use them at the start of the next one. Thank you very much.
Thank you.
Thank you. Take care, everybody.